In this problem, we need to create a straight line amplitude and phase Bode plot. We have h of s is equal to s over s plus 50. We're going to need to convert this to j omega. So we're going to have h j omega, and this is equal to a j omega over j omega plus 50. Now, we need it to be in the form where we have a 1 plus j omega, and then we can have this over something. So what we're going to need to do here is we're going to divide everything by j omega. This is going to leave us with a 1 over a 1 plus 50 over our j omega. Now, if we look at the part right here, we can see that this isn't exactly the same. In fact, it's the exact opposite. So what we're going to do is we're going to take the inverse of it. And so we're just going to have 1 over 1 plus j omega over 50. And then we're going to have a negative 1 out here. And then from this, we're going to look at the k z1 p1, and we can write this in to our conversion. So our z1 is non-existent. We know that in the numerator we have zeros, and this is our z1. In the denominator we have poles, and this would be our p1. So for this, we're just going to have a 1 over our p1, or p1 is 50. So we're going to have 1 over 50. And then inside of here, we are going to have 1 over 1 plus j omega over 50. And this is to the negative 1. And this is our current equation. Now it's time to graph this. So for simplicity, we're going to use a Bode plot where we start at 0.1 here and 0 here. And then we are going to go for 10 to the 0th. We're going to have 10 to the 1st, 10 squared, and then 10 cubed, and then so on and so forth. And then we're also going to have here a 20, 40, 60, we have that. And then we know that this is negative 90 degrees, and then up here with the 20, we would have 90 degrees. And so this is going to become important when we have our phase inflection frequencies, the degrees. The angles are what we're going to be looking at. So for this, unlike the previous problem, we only have two parts. We have this 1 over 50, and then we have this part inside of here. And I'm going to draw this part inside of here in blue so we don't get them mixed up. So looking at this, if we look at the notes linked below the like button in the description, we can see that we have the factor k for like a constant, and the phase of this is going to be 0 degrees. So we're going to have this go all along here, and the angle for this is 0, or the slope is 0 degrees. Now we're going to look at the next part. For this next part, it's actually pretty interesting. We have 1 over our 1 plus j omega over 50, and then this is raised to the negative 1, but we'll include that in a second because normally this is to the n, and we would have basically a 1 here. But since we have this negative in here, it's going to be a negative n, and our n is 1, so we'll have a negative 1. Meaning that the notes that we have, we're going to take that slope, but take the inverse of it. So instead of it going to a negative 90 degrees, it's going to go to a positive 90 degrees. We would basically be writing it like this, and then flipping it. So we're just going to write it the flipped way so we don't waste our time. And we can check where this goes. And we know this is going to go from p over 10 to p times 10. Our p is 50, so this is going from 5 to 500. So on our Bode diagram, we can mark out our 5. We can mark out our 500. And now we can chart this. So everything before 5 is 0 degrees slope. And then at 5, until we hit 500, we're going to have a 20 slope, and this is going to be in degrees. Now, if we weren't in degrees, we'd be working with a dB, and then we have our omega out here. That should do a better omega, but we're working in degrees, and so we're going to be looking at this n. Since we have a negative 1, flipping it, and so it's just going to go up by 20. If we had like a 2 or something, or a cubed, we would just be multiplying the 2 by this. So we'll have this go up here, and then we're going to have it go up here. Okay, that's a little bit off. It's going to go through here, through here. It's a little bit off, but that's just because we're hand drawing it. And then it's going to go up to this 500, and then from here, we're going to go straight like this. So here, we're going to have a 45 degree slope, and then here, we're going to have a 90 degree slope. So when we look at the answers for the 3 inflection frequencies, we're going to see that everything before our 90 degrees is actually, and since we flip this, this will be the 90 degrees, and this will be the 0 degrees. And so everything before the 90 degrees is going to be less than 5, right? Because we have our 5 here, and it's like this. To make sure of this, what we need to do is we need to look at where the slopes differ between the two graphs. So that's at this point, and it's at this point. So we're going to have to draw the Bode diagram for this, and that's combining them. Realized I made a mistake. We did indeed flip this, but we only flipped it across the x-axis. There is a y-axis, and we need to rotate it along the y-axis as well. So to fix this, I'm going to get rid of this entire blue line that we drew. And I'm going to leave the first one because I can't get rid of it without getting rid of the red one. So what we're going to do is we're going to rotate it across the x and across the y, and then this is basically adding 180 degrees to it. So we're going to have this part right here, and well, if this is our 90 degrees, it would look something like this. But since that's a little bit small, well, we'll just stick with this 90 degrees. So we'll have a 90 degrees right here, and then from this point, we're going to have it slope downwards by 20. So this will be 45 degrees, and then everything after this is going to be 0 degrees. Now this makes more sense when we have our 5 plugged into here, because when our omega is less than this 5, we can see that is this 90 degrees. Now we need to draw the Bode diagram to see if this is still 5 and everything's good. So looking at this, if we were to draw a Bode diagram, we would see that it would be along this 90 degrees, because between these two, it would be 90 degrees minus 0 degrees. And then along here, we would have 45 degrees minus 0 degrees, and then 0 degrees minus 0 degrees. So this is basically just looking at the blue line and going off that. So our omega, when it's less than or equal to 5, is still 90 degrees. The 45 degrees is going to be when our omega is this 50. And I've also written down that omega c is equal to 50, and that is what answers this part. So we have 50 here, and then at AdB at 1 rad per second, we'll deal with that in a second. We'll finish filling this out when omega is greater than or equal to what? We have 0 degrees. If we look at this 500 when we go this way, well, we can see that we have 0 degrees, so this is 500 rads per second. Now to fill out our AdB, what we're going to do is we're going to look down here. We have this 20 log 10 k naught, and so we'll have our 20 log 10. We're going to plug in our k naught. We know that our k naught here is 1 over 50. And so plugging this into a calculator, we are going to get the approximate value of negative 34 dB. And that is how we would write out this problem.